Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all in the course of Applications of Information and Communication Technology. I am Dr. Moiz from Department of Computer Science, Allama Iqbal, Open University. I will teach you about unit number 2, which is about processing and storing of data. Let's start with the introduction and objective of the course. As we know that we have data everywhere. We have data in our mobile phone, we have data in our laptop, and we have data in our TV sets. So, we can say that data is everywhere. It is in fact the new oil that can fuel business growth. Therefore, understanding how data is represented, stored and retrieved is crucial for designing efficient system. इसलिए इस यूनिट को हमने इस कोर्स में शामिल किया गया है. This unit explores how raw data transform into meaningful information, the ways it is represented in computers, the types of storage devices used, and how drive performance impacts overall system efficiency. Now, let's come to the objective of this course. By the end of this unit, learners will be able to differentiate between data and information, explain binary and digital data representation, identify various storage devices and their purposes, and explain the concept of drive performance and its effect on computing. Let's start with the first concept of data and information. जैसा कि आप जानते हैं कि किसी भी कंपनी में जब किसी प्रोडक्ट को बनाया जाता है तो ख़ाम माल का इस्तेमाल किया जाता है. अब ये ख़ाम माल इनफरादी हैसियत में हमारे किसी काम का नहीं है, लेकिन जब एक प्रोडक्ट तैयार हो जाती है तो उस प्रोडक्ट की अहमियत बहुत ज़्यादा होती है. तो ये ख़ाम माल बेसिकली क्या है? ये ख़ाम माल ही हमारे पास डाटा है. आइए इसकी फॉर्मल डेफिनेशन देखते हैं. डाटा इज़ अ कलेक्शन ऑफ रॉ फैक्ट्स एंड फिगर्स यूज्ड फॉर एनालिसिस और रेफरेंस. It is unprocessed facts that can be recorded, measured and analyzed. Think of data as ingredients of a recipe, not meaningful on their own. Let's have an example of data. A student's admission form contains raw facts like student name, father name, address, date of birth, previous education details. At their own, these data items are meaningless, because these pieces of data don't tell us much about the student's academic journey or potential. We can convert this data into some meaningful information. So, let's have some discussion about what is information. Information is the data that has been processed. Information is interpreted data. Information is meaningful. So, we can say that information is the finished dish made from those ingredients. It is tasty and eatable. Let's have some examples on data and information, and we have a table in which we have data and information given. In the first example, we have marks of a student 85, 90 and 78, but this is meaningless information. And if we interpret it like a student scored 85 in math, 90 in English and 78 in science, now it is meaningful information. Second example, we have temperature of a city like 22 centigrade, 25 centigrade and 27 centigrade. It is again meaningless, but if we interpret it as temperature increase gradually over 3 days, now it is meaningful information. In the third example, we have some responses from a survey, and we have like yes, no, yes and yes, but again we are unable to understand what is this. If we represent it like 3 out of 4 participants responded yes to the survey question, now it is meaningful information. In the last example, we are given that a user A clicked 5 times, user B clicked 2 times again. This is meaningless information, but if we write it as user A is more active on the website as compared to user B. Now, how can we convert this data into some meaningful information? We have some basic steps that start with the collection of the data, and these steps are collect, meaning get the data, clean, fix errors and remove noise, organize, combine and arrange it properly, analyze, find patterns and insights, and presents share results using visuals. Let's have an example. As you know, you all students, they have filled their admission forms. In the first step, a student fill online admission form where they provide their credentials. University receive your data, but if there are some incomplete or incorrect information, then we have to remove incomplete and incorrect entries. In the third step, we organize the data like store data in a structured way, which can be program-wise information or region-wise information. In the fourth step, we analyze the data and we find the trends, like we would like to know most applied programs in which maximum number of students have applied, or we would like to know about the regional stats, how many students are enrolled in different regions. In the last step, we present the data using charts and tables. Our next concept is about the data representation. जैसा कि हमें पता है कि किसी भी कम्युनिटी में जब दो लोग आपस में कम्युनिकेट करते हैं तो इसके लिए ज़रूरी है कि वो एक दूसरे की लैंग्वेज को अंडरस्टैंड कर सकें, उसको याद रख सकें और उसका मुनासिब जवाब दे सकें। इसी तरह जब एक यूज़र और कंप्यूटर आपस में कम्युनिकेट करते हैं तो ये बहुत ज़रूरी है कि वो दोनों एक दूसरे की लैंग्वेज को अंडरस्टैंड कर सकें। लेकिन यहाँ पे हमें ये जानना ज़रूरी है कि कंप्यूटर किसी यूज़र की लैंग्वेज को डायरेक्टली अंडरस्टैंड नहीं कर सकता। इसके लिए वो बाइनरी नंबर का सहारा लेता है और यहीं से हमारे पास डाटा रिप्रेजेंटेशन का कंसेप्ट आता है। तो व्हाट इज़ डाटा रिप्रेजेंटेशन? It is process of converting real world data into a format that computers can understand and manipulate. And why is data representation important? Because it enables computers to store, process and communicate data efficiently. Now we move forward with data representation. We have an important concept about the binary number system. Computer use the binary number system to represent all type of data. And what are binary numbers? Binary digits can be 0 or 1, and these values are used to represent either off, on, false, true, no, yes. And now the question arises that why computers use binary numbers? Because they are easy to implement with digital electronics and they are reliable for processing and storing the information. When we talk about the binary numbers, we have bits and bytes. Now we start with the concept of bit. What is bit? It is the smallest unit of data in a computer. It can be only 0 or 1, and it is used for representing simple states like on and off, as discussed earlier. Now we come to the concept of the byte. Byte is a primary unit of data storage that uses bits. It is a group of 8 bits which is equal to 1 byte. Now the question arises that why do we use byte? Because they are used for representing letters, numbers and symbols, as you can see on this slide. We move forward in the topic of data representation. Now there comes the concept of encoding schemes. Computer need rules, encoding schemes to convert data, that is letters, digits, into a binary format. So what are encoding schemes? It is the process of representing characters such as letters, digits and symbols as numeric codes. Encoding helps in storing, processing and transmitting data correctly, and we have some common encoding schemes like BCD, ASCII, ASCII and Unicode. The popular coding schemes to represent data are BCD, which is the abbreviation of binary coded decimal. It represents decimal digits 0 to 9 in binary form. Then we have ASCII, which is the American Standard Code for Information Interchange, and they are used for representing English text characters. Next, we have ASCII, which is Extended Binary Coded Decimal Interchange Code and mainly used on IBM mainframe for text representation. In the last, we have the Unicode system, which is Universal Character Encoding, and that supports character from all world languages. Let us see an example. How is a letter converted to binary from and back? Let us see an example. How is a letter converted to binary form and back? In the step number 1, the user presses the capital letter D, therefore, he uses Shift plus D command on the keyboard, as you can see in the figure. In the step number 2, an electronic signal for the capital letter is D is sent to the system unit. In step 3, the signal for the capital letter D is converted into ASCII binary code and is stored in the memory for further processing. And in the last step, after processing the binary code for the capital letter D, which is converted to an image and displayed on your screen. With data representation, we have the concept of number conversions. And what are number conversion systems? It is the process of changing a number from one number system to another, because as we know that human use the decimal system and computer use the binary system. But what are the decimal system? Decimal is base 10 and has 10 digits, starting from 0, 1 and it goes up to the 9. And what are binary? We have already discussed that binary is base 2 and has 2 digits, that is 0 and 1. Now, we will see some procedure regarding converting decimal to binary. There are 5 basic steps that we will discuss. Number 1, divide the decimal number by 2. If you are given a number, you have to divide it by 2. In second step, write down the remainder, which will be either 0 or 1. In third step, use the quotient for the next division, and we will repeat this process until the quotient becomes 0. In the last step, the binary number is the remainder, read from bottom to top. Let us see this procedure with the help of an example. Suppose we are given a number 11, which is in decimal form, and we want to convert this number into a binary. So, in step 1, we will divide 11 with the number 2, and we know that we have 2 5s are 10. So, here our quotient is 5, and if we minus 10 from 11, we will get the remainder 1. Now, we go to the step number 2, we have the quotient 5, we will again divide it with 2, as we know that 2 multiplied by 2 is 4. So, we will get the quotient 2 here, and the remainder will again be 1. In the third step, we have the quotient 2, which we will divide again with the 2, and we will get the quotient 1, because we have 2 1s are 2, and we have the remainder 0 here. In last step, we will divide 1 divided by 2, but as we know that 1 is smaller than 2. So, we will get the quotient 0 and the remainder will be 1. So, we will get the least significant bit, which will come on the right side, and the most significant bit, which will become on the left side. So, binary equivalent of decimal number 11 will be equal to 1 0 1 1, as you can see in the slide. Now, we discuss how we can convert a binary number to a decimal number system. There are 4 basic steps. In step number 1, we will write the binary number. In step 2, assign power of 2 from right to left starting with the power of 0 of 2. Assign power of 2 from right to left starting with 2 raised power 0. In the third step, we will multiply each binary digit by its corresponding power of 2, and in the last step, we will add all the values together to get the decimal number. Let us see with some example. Suppose we are given a binary number which is 1011, and we want to convert this number into a decimal form. In the step number 1, we will take the first digit from right, and we will multiply this digit with the 2 raised power 0, and we will get the answer, which is 1. In the second step, we will take the second digit, which is 1, and we will multiply it with 2 raised power 1, and we will get number 2. In the third step, again we have the digit 0. Now, the 2 power has become 2. We will multiply both, and we will get the result which is 0. In the fourth and the last step, we have the 1 digit, and we will multiply this digit with the 2 raised power 3 and we will get the result 8. Now, we will add up all these values, that is, we will add 8 plus 0 plus 2 plus 1 and we will get the 11. So, 1011 in which is in binary form, its decimal equivalent is 11. जैसा कि आप जानते हैं कि कंप्यूटर्स को डाटा और इंस्ट्रक्शंस को अपने पास महफूज करने और स्टोर करने की ज़रूरत होती है ताकि वो इन रॉ डाटा को प्रोसेस करने के बाद कोई इन्फॉर्मेशन जनरेट कर सके। तो यहाँ से हमारे पास स्टोरेज डिवाइसेस का कंसेप्ट आता है। आइए इसकी फॉर्मल डेफिनेशन देखते हैं। Data storage is the process of saving digital information on a computer system, and it holds or saves data and instruction required for processing, which is received from input devices that the user has typed. Secondly, it stores intermediate results of processing and the final result of processing before they are released to an output device like the monitor. We have two important type of storage devices, like we have the primary storage devices and the secondary storage devices. We start with now the primary storage devices. The primary storage devices store running program instructions that are in use. That is, they store the active data, they store the intermediate results and results of ongoing processing of the jobs. And what are the characteristics of primary storage devices? These are, they are fast in operation, has a small capacity, but expensive to purchase. Now, we see some examples of the primary storage devices. We have the random access memory, which is also called the RAM. RAM temporarily stores data and instructions that the CPU needs while performing task. And we have some common types of RAMs, which are DDR3, DDR4 and DDR5. And DDR stands for dual data rate, and these are based on speed and bandwidth of the device, and DDR5 is better than DDR3 and DDR4. The next storage device is read-only memory, which is also called the ROM. It permanently stores firmware and essential programs required for booting the computer. And what are firmware? Firmware are low-level software programs which are embedded within hardware, and they are used to control this hardware. In common types of ROM, we have EEPROM and EEPROM. EEPROM stands for erasable programmable read-only memory, and EEPROM stands for electrically erasable programmable read-only memory. When data and instructions needs not to be changed, we use EEPROM, and when they are required to update, we use EEPROM. Next, we have the third example of primary storage device, which is called the CPU cache. It provides high-speed data storage and access to the CPU, storing frequently used instructions and data, and they are integrated directly into the CPU chip. Let us have some discussion on secondary storage devices. Secondary storage devices store program and instructions permanently, which are not in use. They hold data information of the saved jobs, but they are slower than the primary storage. There are some important characteristics regarding storage devices, that they has large storage capacity, much cheaper than primary storage, and non-volatile, meaning retains data without the power. Now, we see some examples of secondary storage devices. We have the hard disk drive HDD, which is a magnetic storage device with moving parts used for high capacity data storage. Then we have solid state drive SSD, which is a fast and durable storage device, use flash memory with no moving parts. ये solid state का concept हमारे पास physics से आता है, and these are hard solid state drives in which data is stored in electrical circuits, and which helps in moving efficient transfer of data. Then we have optical disc, CD, DVD, and these are laser readable disc used for storing media and data like music, videos and backups. Let's see some more examples of secondary storage devices. We have USB flash drive, which is a portable plug and play device that uses flash memory for quick file transfers. Then we have memory cards, also called the SD. These are compact flash based storage commonly used in cameras, smartphones and handheld devices. Finally, external hard drives are also available, and these are portable storage devices used for data backup and expanding storage. The last topic of today is the drive performance. Let's start with the formal definition. What is drive performance? It refers to how efficiently a storage drive can read, write and transfer data. It is critical factor in overall system performance. It manages data access, storage and retrieval and ensure optimal performance for applications and system programs. There are some key parameters which are related to drive performance, and these are read write speed, which is measured in megabits per second, and it tells us how fast data can be read or write from the drive. Then we have IOPS, that is the number of read write operations that can be performed in 1 second. We have latency, time taken to respond to a data request, access time, time to locate and retrieve data, queue depth, number of I/O operations the drive can process simultaneously. In the last, we have the endurance, which is how much data can be written to the drive before it may fail. There are certain steps that we can take to improve our drive performance, and these are: use SSD instead of HDD. We have discussed about SSD and HDD in previous slides. Always install the latest drivers related to your drives. Maintain system resources, that is, ensure enough RAM is available to execute your programs. Also, monitor drive health regularly. Upgrade your hardware and use some tools like Crystal Disk Mark, HD Tune, SSD Live, Windows built-in defragment tool and disk speed test. Dear students, let's finish the today's lecture. I hope that you have understand the concepts. Let's meet in some other lecture with some other topics. Allah Hafiz.